As industries evolve, the demand for metals with advanced properties has never been greater. From extreme temperatures to weight constraints, each sector has its own unique challenges. These challenges drive the need for materials with enhanced properties, making advanced materials the future of metal alloying. To meet these growing demands, alloy researchers are adopting experimental methods to create alloys that push the boundaries of material performance. For example, high-entropy alloys composed of 5 or more elements are proving to be highly adaptable for extreme environmental applications. Metal matrix composites, which incorporate other metals or ceramics as reinforcements, are commonly utilized in fields like aerospace and automotive industries. And functionally graded materials, designed with gradual variations in composition, are ideal for functional components that require distinct properties at different locations. The process of researching and producing these alloys is far from simple. Each sample requires multiple complex steps to fabricate, and even then, it's impossible to know how many iterations will be needed to achieve the desired properties. This uncertainty highlights the need for a faster, flexible system. In response to these challenges, 3D printing offers a powerful solution for alloy research. Known as laser powder-directed energy deposition, this technology feeds metal powders through a nozzle, while a laser creates a melt pool, rapidly solidifying the material to form metal samples. MXLab, a 3D printer specifically designed for alloy research, utilizes LPDED to produce precise metal samples. This machine is equipped with a DED system that includes 6 independent metal powder feeders. So, up to 6 different raw materials can be independently prepared, and based on user inputs, each is fed and mixed to create alloys with variable compositions, all without additional material prep. It takes approximately 40 minutes to produce a sample of a 10mm cube on the MXLab, with minimal material waste. The ease of operation also allows researchers to quickly create a variety of samples with minimal effort. Discover the future of alloying today with MXLab.